Thank you for joining me. Today we're going to talk about RAG-based AI systems. You may have heard this concept, RAG. It stands for Retrieval-Augmented Generation. It's actually a fancy term for a concept that's pretty straightforward. The goal of a RAG system is to give a model access to external data to better be able to perform its task. Why is this important and why do we need to do this? Well, a large language model is trained on a lot of data, but it's trained on it for a couple of purposes. The first one is to teach it how we speak. What do our words mean semantically? How can I use everything else that I know to respond to your words with AI's model's words that make sense? It's a natural language processing task. And for it to do that, we also need to teach the model skills. We teach the model how to classify groupings of text into related subjects or related areas. We teach the model the skills of summarization. Given a body of text, break down the key themes and pull out to create a summary. We teach the model how to recognize when we've asked it a question that's looking for a factual answer. Given this block of text, answer my question, pull out the most relevant text that would answer my question. We teach the model lots of skills, and we give the model a lot of reference data as well. The more reference data that we provide it, probably the more fine-grained of an answer that we can get, a more detailed answer. And arguably, access to more data than a smaller model might have. And so it has more to pull from. So we take all that information, we bake it in, it's used as reference. We've taught it how to understand this, and we've taught it how to perform skills. And now we have our model. But the model doesn't know everything. It stops at the day that the model was trained. Any information that you asked that was created after the training period, the model doesn't have a concept of. It doesn't know what that means. So it can't answer your questions. I know it's sad, but we didn't expect it to do everything. And yet, we still have burning desires to get questions that the model doesn't know answered. And we may not even know that the model doesn't know it. We may throw our questions and things in, get back gibberish, and say, "Oh, whoa, wait a second. I wanted you to be focused on these things. Let me help you out. Let me put some gates around here. I'm going to give you this external data as a reference for you to then go ahead and answer my questions because we figured out the AI doesn't know about it." Another example may be private data. Well, if it's scraping the internet, it's not going to be able to get to your private data, so it doesn't know anything about that either. And so we need to provide it that data. We'll take that document, we'll copy the text, we'll paste it into our prompt, and then we'll ask the question, what does this mean? Well, the model can do that now because you gave it the proper context. It works just fine. But that's kind of what a RAG system also attempts to accomplish. So what we'll do today is we'll go over the concepts. I'll explain the big concepts behind RAG, and then we'll just dive into how's this useful? Where is it useful? And how does it compare to our other options? Hey, when we're done with this, you'll understand what RAG is. You'll understand where it could be applied and some of the pros and cons. This won't be super technical. It'll be at a high level. You're not going to be able to go build this by yourself at this point, but you'll certainly understand the importance and the relevance of having one. And you should be able to start to see where you might be able to apply one in your companies or in your AI workflows in general, or even some of your projects. So with that, let's get started. Our first concept is data gathering. It's misleading because you know what? I'll just get into it. When you think about this, of how you would find the right information when you have lots of it. Let's say it's a corporate database or several corporate systems, different systems of data that you have. You could run a query. You could find the most relevant documents that have to deal with your question, pull those documents, and send those along with your query to the large language model and tell it to find your answer. But there are a couple of problems with that. The first is that the LOM has a fixed size of information that it can consider when trying to answer a question. This fixed size is its context window. And your prompt plus the data that you send across, they count. So the sum total, the sum size of both of those affects how much space that you can use. If you have a long prompt and then you have a lot of data, you're probably going to hit that limit. If you had a short prompt, but you had a lot of data, you still could hit that limit. And then your model is just going to politely tell you it can't do it. It's going to say, you gave me too much information. I can't handle it. And it's not really going to say it, but that's what's going to happen. It's not going to be able to work on that question, that problem, because you overloaded it and it can't handle it. And each model has a context size that it can work with. A large language model has a bigger context window than a smaller one. So you can send more data to this one, but you still can't send infinite amount of data. And if the relevant pieces were just smaller subsections of the document, it was actually kind of wasteful then to send all the rest of this documents. You just need to send those smaller sections. But that's not the only problem. You actually, in this scenario, ran your own query. You created the prompt that you wanted the model to solve, and then you went to your databases in other places and you pulled back the documents that you thought would make sense for the model to have. And then you sent it across. Well, you just did extra work. And if you realize, wait, I sent the documents, they were too big, the model wouldn't handle it. Well, I need to go through these documents that I created. I need to find the most relevant sections and just grab those and then add them to my prompt and send them across. You still did the work and you did more work. And arguably, it made no sense for you to do that. What was the point of having the large language model handle your questions if you have to go find the external data each time and then find just the relevant sections to send across? It would be too much work. No one would really want to do that. You want the black box experience. You want to just create your prompt, send it through the black box, and get an answer out the other end because the large language model took care of it, or your system. That's all you want. You don't want to do the extra work. Your work was gathering all the data to put in the first place. So how do we solve this? How do we take you out of the mix? Because really you want to send it, you want the detour to happen to pull the right data and then put them together and send it to the model and get an answer. This detour part is the part we're going to cover. That's the data gathering. You have data that you want to use, and now we need to index it. Because in order for the model to find the right stuff, it has to understand what the data is. And it doesn't understand words. So indexing is like a 3-step process. The first step is that we have to load the data. And what I mean by loading the data is that we have to pick a consistent format that all the data is going to be in so that it works for the system. If you want to use folders full of documents and you label all the folders, great. That's your system. You're using folders full of documents, and that's how you're grouping them. If you wanted to add additional data to each one of the documents, well, you may choose a structured type of format. You might choose something like JSON, which allows you to add extra metadata. Maybe all of your data didn't come from the same system. Maybe it came from different systems on your corporate network, where you could annotate each bit of data that you're going to store with where it came from. And now you've stored it in a JSON format. And that's going to help you later if you need that level of detail. So you've now stored the data. You've now loaded the data. You've gotten it all into a consistent format. You did it for everything that you needed. Now what? Well, if you stopped there, you'd be sending the same large documents across, but maybe you had more metadata, but you have the same problem. So you need to split all of this data into smaller bits, smaller pieces, chunks, as we like to call them, so that when you find the relevant chunks, you're sending just the chunks. And it's much easier for a model to search through and find the right relevant chunks and send just those than it is to send large documents and try to find what you need to there. So what do? We literally define a size for where we want to split each of our documents, the text that we have. We load the documents, and at every chunk size, we split it. And we have individual chunks. And each chunk has lots of words in it. And our splitters are smart. They're specialized splitters that we use. It's not going to split a word in the middle of it. It's going to try and group as much of the words in the, as part of a sentence or whatnot together before it splits. So it's trying to maintain the size and be true to that, but it's smart about how it splits. And it keeps the order. It would do you no good if it scrambled the order of words in the chunks. It wouldn't be useful then. So it keeps the right order, it keeps the chunks in the right order. And now you are beginning to have something that the system can use. But you still have words, and the model doesn't understand words. But what the model does understand are mathematical representations. We convert each word that's in a chunk into a vector. This vector is also known as an embedding because it uses special rules for how it creates the numbers. But each vector, each embedding, is still contained within the chunk. So it's still grouped together. But it's in a representation that the models in our systems can understand. So we break them into embeddings of our groups of chunks. And that covers our second part, which is splitting. All we have left to do is to store it. But we can't just store it in a database in this traditional sense because now you just have numbers stored someplace and it makes no sense whatsoever. So we need a special type of database to store this in. We have vectors of all these different words. Would you be surprised to know you're going to store this in a vector database? Of course you are. I mean, we're going to use a vector database to store all the vectors. It's the only thing that makes sense, of course. So we do that. And now we have all of our data indexed in a way that a computer system, would understand how to work with. So we've now created and set ourselves up for you not to be in the middle, for a system to be able to understand what's in there. So when it's given your question, they don't know how to go and find the most relevant stuff. And so that's data gathering. That's really data indexing to get our stuff stored in a database, the pre-work, to be able to be useful when we want to retrieve and ask our model questions. We have our information stored in our data store, in our vector database, and we're ready for our last concept, the retrieval part. We use special retrievers, and in this case, one that understands vector databases that'll take our user's input and convert that into embeddings, vectors, that match those that are stored in our vector database. We need to then search our vector database to pull back the things that are related. And our retrievers are good at that. They know how to do that. But not as good as our large language model. If we were just plugging our stuff into the large language model over here, we just send over the text, the model would convert it into those same embeddings, and it's been trained on how to find this stuff in its own system. I mean, it's been trained a lot, and the model's really good and really big. Just like that, it would have it. But we don't get to use the model at this stage. So we have to do something different. And our retrievers are the closest thing that we're going to get. And it's not trying to find the exact answer. It's trying to find things that are related to the user's question. So it's doing a semantic similarity search. It's taking what it has and trying to find things that are close. And when it finds the chunks that are close, it brings those back. We're not going to go into exactly what that semantic similarity search looks like, but I'll tell you it's all math. And they have things like cosine similarities that find things that are in the vector space that are most closely related. Let's punt on all that and just say the semantic similarity search finds the chunks of data that make the most sense. We pull those chunks back, we convert all those embeddings back to text, and then we attach the text and group them back till we have sentences and thoughts. And that data is the data that we'll send along with our prompt to then do the rest of the magic. Almost. Our model is just expecting user input. So it doesn't know anything about the additional data that you're calling context. It just thinks it's all part of the user input. So we just need to make a little twist there, a little tweak there to change what the model is expecting. Our large language models have a system prompt, and that's just its instructions for how to deal with user input when it gets it. We can modify that. We can update that system prompt to let the model know that not only are you going to get a user input, but you're also going to get this extra data that you should use as the context for dealing with this user's question, its input, the task. And so once we do that, we can now send over both the user input and this contextual data, and the model will be just happy to do the things it was trained to do to give us our text. And then that's it. We've now gone through the whole process. We did our pre-part to get the data ready and to store. We did our retrieval part, which was to take the user's input and then to pull things back. And we did our generation part by changing the prompt so that the system, the model knows to expect both the user's input and this contextual data to do the rest of the job. So we've just enriched our model with external data. And it's dynamic this time. You don't have to copy and paste to put anything in to get the model to do the things that you want. You spend a little bit extra time, probably a lot, cleaning and crafting this data to put in your data store. But once you have it, it's going to be easy to maintain later and going forward. And so that step allows you to do more of this. If you want to update your data or change it or get rid of stuff because it's no longer makes sense, you can do that and you never affect the model. To the model, all it knows is that you're going to send it user input and you're going to send it some extra data to use. And it's going to be happy because it's going to think, well, I didn't have that data. You've given me the right data. I know how to use my skills to do the rest. Okay, we're into the home stretch. We have now covered exactly how a RAG-based AI system works. We provided additional data that the model doesn't currently have. It can be dynamic, it can be modified and updated, and you never have to touch the model to change it. To the model, it's just receiving user input and additional data. So it works perfect from that. It's also pretty efficient from a cost point of view to work with and maintain. The hard work is the initial setup and finding the data, putting it in the right format, and storing it. But once you have that, if all you're doing is adding additional data along the way, it's pretty easy to do. And it's something that's maintainable. Your alternative to that is to fine-tune the model. Fine-tuning is what we started with. When we built our model initially, we basically had to fine-tune it to behave the way we wanted it to. So to add additional training to the model, to change the way it responds in certain domains, well, that makes sense too. If you knew that the types of questions and the types of things that you wanted this model to behave on were very domain specific, had its own vocabulary, and didn't change very much. What it needed to know how to do could almost be static in nature. Well, you can bake in new instructions. You can bake in a new layer for this model to be able to behave in that way. Going back to the case of medicine or so, or the medical field, you could have this model know what the vocabulary was so that when it received input, questions, tasks from the user, it understands that vocabulary, understands that, hey, what this means in the medical field could be different than a general model. I have good knowledge now, and I can use that to deal with the user's scenario. And that may be very important for this. You maybe it's something that you can't afford to have that kind of a mistake. And so knowing that you have a model that knows how to behave and to work with certain data gives you some series of protections. But it's more costly to train. And it's easy not to be up to date. If things change kind of rapidly or unexpectedly, you have to retrain this model. And that's resource and time intensive to do. If you had to do it once or twice, not as big a deal, but if you foresee yourself having to do this very often, this can become very costly. Even if you're just fine tuning portions and layers of this where the costs have come down, it's still very time intensive to do. And so, in a situation where you knew things were changing a lot, this may not be your best option. The option of having the dynamically generated, data that you can have that you can constantly update and just provide to a model may be a better option. In fact, if you had private documents or documents that you didn't want stored and baked into a model, this is a good option for you. If your data came from lots of systems and you knew that it was going to be changing a lot, again, this is your best option. Another area where it may not be as clear would be that sometimes these models, when they don't know how to answer because they don't have that data, they lie. It's hallucination. So using a system that can be more dynamically generated or that you can kind of pull this information from, you can help guide your model and give it the guardrails in a sense to stay within the box. You're providing it the context, the data to use to answer your questions. You're going to be able to trace it back to like where it got the answer from, and you'll be able to more easily decide if it told you the truth or not. That's going to be a harder thing to do when you don't have the exact source that this fine-tuned model used to answer your questions. Now, I'm not saying that this is bad and that you can't trust it. I'm just saying that there are times where, a more dynamic generated system that can be more up to date, that you could change, provide different relevant data that can be pulled and used when a user asks a question, could help you narrow things in and get closer to the types of responses that you're looking for. So, are these mutually exclusive? Can you have one and the other, or is just one or the other? Well, of course, you can use them together. And there are situations where the task that you're trying to solve for is pretty complex. And the benefit of having a model that's fine-tuned that understands to speak the language of that domain that's very specific can be really good. But that data and its knowledge is also baked at that point. It understands how to respond if it receives new data based off its rules, but it doesn't have that new data. It won't be always up to date. If you had a RAG-based system as well, you can provide that new updated data and you don't have to change this model. You don't have to do another level of fine-tuning. You can just provide it additional information, additional external information to allow that to happen. And so you can have the best of both worlds in those situations where those tasks are really complex. So you can walk away from this realizing that you have choices and that in some cases, choosing both will make sense. Well, that concludes this talk, this conversation that we've had. I've taught you what to look for in a RAG based system based off of my knowledge. And I've given you some of the reasons why you might choose it or why you might choose to fine tune something. It really does have a lot of uses within a business. Just starting. Out of the box, you can look at this and say, I want to train on my company data. It's private and it changes. I might use this RAG based system. I might be able to get it up to speed faster and quicker and realize that I have some time and some leeway to make some mistakes and kind of keep working with it. That might work really well. Okay, we're wrapping this up. I've covered all that you need to know about RAG based systems without going too deep into the technical weeds. I will say that it is still somewhat hard to do that, and I can't gloss over everything. But I am trying to make it approachable that if you are interested in AI and some of the things that are related to it, you can at least get a gentle introduction to them with these types of videos. Honestly, if you're really trying to dive into the really nitty gritty technical things, there's a video for you and a channel that will have that. This is meant to be more approachable. This is meant to give good intros and to cover some of the topics that are, it can be a little rough, but to do it in a way that minimizes the terms and puts more emphasis on how things are done and kind of why. So, thank you for watching this. And if you're listening to the podcast, thank you for listening. You can find me on social at keithelliott.me. And that'll have all my links to all my social platforms and ways to connect to me. Subscribe to this channel, subscribe to the podcast, and sign up for the newsletter. The newsletter is actually going to have a lot more tips, and you can digest that in your own time. I'm not going to spam. But I do enjoy making these, and the way to keep doing it is to grow the channel. The way for me to have impact and to reach more people is through word of mouth and through subscribers. So once again, thank you for listening, and I hope to have you join in the conversation for my next episodes.